Even if we'd all like to enter the TARDIS then change the time periods, regrettably time is linear. It advances by one step at a time, 1 second at a time, and as time passes, so does the universe and everything inside it. Why the universe continues to grow? Because it has been acting in that way since the beginning of time. But what if the universe decrees no longer? Will there be any what-ifs? Down and declares that it will not move any farther. Hello and welcome to KYC News, and let's see what happens today. If the universe stopped expanding, what would happen? The cosmos is expanding because of constantly awake and always advancing through time. Some would contend that it is the movement of the cosmos that results in the shift that is explicable. Whatever happens as time goes on, I think you'll come to the same conclusion. A chain can be used to describe space-time. Of things that always occur in harmony. Indiana, the universe, things travel through space, and their velocity is related to time. Numerous influences, including, can influence how they move. Because of gravity, the cosmos is still expanding. Since time and space are connected, entropy also accountable for the universe's expansion. Everywhere you look, entropy is increasing. From system to chaos, the universe will always transition. Additionally, it cannot be undone. You cannot unbreak a broken mirror in place of the scrambled eggs, or the universe can be put back together into a new mirror. Some things defy the laws of thermodynamics. Argue that there is no evidence to support the linear thermodynamics' root is related to the when Edwin Hubble found the timeline galaxies diverging from one another in 1929. Researchers understood that the universe must. This was a perfect justification for the expansion. Because of the paradox that has bothered me since the era of the ancient Greeks, mankind is the early universe endless or finite? Heinrich Ober's, a German astronomer in the 1800s, contended. Ober's previously asserted that the universe must be limited. If the stars in the universe were endless, if you looked at that time in any specific where eventually your line of sight would go on a star's surface, despite the apparent the size of a star in the sky diminishes as the brilliance of the star increases with distance. Because the smaller surface doesn't change, the entire surface of the cosmos would be finite. Should shine as brightly as a star in the night sky. There are certainly black regions in the sky, so if the universe is limited, then why Isaac Newton realized the existence of the law of gravity. That gravity always pulls all objects, and objects in the universe are drawn to one another. If the attracting forces in the universe really were finite, of everything in the cosmos ought to have caused the collapse of the entire cosmos. This obviously did not occur, therefore a conundrum was posed to astronomers. That our universe is both limited and expanding resolved. The underlying cause of the universe did not collapse as predicted by Newton's equation, perhaps because it had been constantly growing. Discovery also led researchers to conclude that if considering that the cosmos has been constantly expanding since the moment of its establishment, it has in the past, they must have become smaller and smaller. Hence, the entire cosmos existed at some point in time, perhaps compressed into a singularity. However, that doesn't resolve even one issue. What led to the universe's expansion? Some physicists attribute it to dark energy. Believe that dark energy is present and that this the cause of the galaxy's repulsion to. However, as far as human knowledge goes, dark energy is constrained. Its potential is unknown. If the situation were to change in the future, would the universe start to collapse in on itself or keep the time reversal symmetry stationary? Unfortunately, we are unable to test this. However, the laws may provide a solution. Interestingly, the rules of physics provide a very intriguing idea known as due to time reversal symmetry. The laws, whether you run or not, the laws of physics hold true. Neither moving the clock ahead nor backward is necessary. Think about it. There are many instances to consider. Symmetry of time reversal exists in our universe for two billiards as an illustration of elastic collisions on a pool table. Balls collide with magnetic objects. Even the strong nuclear forces are drawn to one another. The mechanism that holds atomic nuclei together is same in time, both forward and backward. And how can we overlook that incredible video of Walter Lewin, a physics professor, describing the mechanism of kinetic energy by putting his own head at risk with a pendulum? But there is a well-known exception: time dilation. The force is symmetry, weak nuclear interaction. if we disregard, is accountable for radioactive decay, the physics-based laws actually apply to such anomaly. Identical whether time moves forward or backwards, if time reversal symmetry holds, if you could end up in a fatal situation at any time. There is always a way to return in due course. Your starting point, if you simply use the appropriate series of events that happened in the ideal order, some of us call it reverse because we do it every day. Nonetheless, if your system is very complex, then you'd need to be aware of stuff like the exact improved understanding of your particle locations and momenta accuracy, then quantum mechanical possibility exists. For instance, if you crack an egg, it will scramble. You could never undo anything once you boil it. If you push a glass, you can unbreak and unscramble an egg. Watch it crash against the shelf. As you take it off, you won't see those pieces of glass rise up from the floor and reconstruct themselves here on their own. There is no turning back time, entropy prevails. Moving on from the thermodynamic principle, the rules of thermodynamics are essentially the arrow of time claim that there are only a limited amount of options, that your system's particles can be organized, and those with the greatest number of potential arrangements, like the ones in what we those who refer to thermodynamic equilibrium, as time goes on, all systems will tend in that direction. Is it already slowing down? That expansion determined that ever after the recent big explosion, despite the fact that the cosmos has been expanding, is not expanding as quickly as it once did. Additionally, the universe has become much cooler translates to the fact that even though the same constant 1 second per second speed, the universe's growth is slowing, and that the possibility that time and thermodynamics are not linked as closely as many believe. The expansion of the cosmos was much faster, currently expanding more slowly than in the past to a limited positive value, but if dark energy develops into a state that there's a chance the cosmos will stop expanding, would gravity then force the cosmos to shrink? Consequently, if you consider an expanding universe and it using the time reversal symmetry, it will result in a contracting universe for you. However, there are pros and cons to time traveling backward. Entropy persists even if the universe is expanding. Remain still, gravity would still pull things toward it. Things to one another, falling particles exchange will still occur into a bound structure. Elastic and inelastic transfer of energy and momentum collisions, the particles of ordinary matter they will lose angular momentum and collapse, still experience atomic and molecular changes, can produce light using many types of energy, and even if the entire cosmos stood, in plain English unmoving, and everything started to gravitate toward it, even if the entropy of the cosmos decreased. Hence, even though the cosmos will eventually contract, resemble reversed film of a universe in expansion, time will continue to advance. We can see that happening right now, since the main motivator, the existence of entropy in our cosmos, as well as the creation of supermassive black holes. The supermassive black hole is real. Alone in the Milky Way's nucleus, then the entire cosmos, and entropy immediately following the explosive big explosion. Time would advance not simply because of as far as we know, but the previous moment there would be more entropy in the Big Crunch than in the when the universe first began, the scorching Big Bang. Planetary systems will converge into stars. Black holes will combine into black holes, larger black holes, until all matter and energy is absorbed, merge into a single little in the cosmos. Fascinatingly dense spot at an endless scale will continue to go forward, but not without impacted by the giant planet's gravitational pull crunch that we would unavoidably find ourselves in. The event horizon boundary of a black hole, and as we moved forward, time grew longer for us, extending the duration of our last moment until infinity. There would be a race of some kind happening as we entered the core singularity of a black hole, and every singularity would combine to create to the eventual end of our cosmos in a large crunch, which prompts the inquiry, what comes next? Would our universe then unfortunately come to an end? Would it create a brand new universe, where this major crisis might trigger another major boom, or would the person's gestation period involve a bang? Knows how long, because time simply vanishes. That, even if it's imperfect, is the beauty of the universe. Finite and will eventually get old and pass away, It begs the query, if we head to the edge of universe and reach out beyond the limit, tell us in the comments what's on the other side. What do you anticipate transpiring at the end of time? Thank you for watching as always.